All right, ladies and gentlemen, so we're going to talk about difference of perfect squares factoring. Excuse me. Difference of perfect squares factoring is built off of the idea of conjugate multiplication, which you've seen before. And I have different signs, and I FOIL this out. I end up with a squared minus ab plus ab minus b squared, which is going to end up being a squared minus b squared. So when we factor here, we're trying to make sure that we're factoring out difference of perfect squares. So I need a perfect square up front and a perfect square in the back, and I need a minus sign in the middle. Okay, so if I have a minus sign in the middle, then that could be difference of perfect squares. There's no such thing as sum of perfect squares. You cannot do the sum of perfect squares. It will not work. So if you're trying to do that, you're going to be wrong every single time. Don't. And you need to know your perfect squares. I've talked about this before. Perfect squares mean obviously perfect square numbers, but also perfect squares by way of having our variables. And to be a perfect square variable with a variable, it needs to be even. X squared minus 64. Two numbers whose product is going to be x. It's x and x. One gets a plus, one gets a minus with the 8, because 8 times 8 is going to give me 64, negative 64. Now, it could have been x minus 8 and x plus 8 as the two terms. The order is important by way of where they go. X, then followed by a plus or minus sign, then the 8, and the other being the x and the other sign with the 8. You can't just switch the 8 and the x around. That doesn't work. Okay, so you have to make sure when you're doing this, and you check back by foiling, that you are actually doing the correct breakdown of the numbers. All right, so let's take a look at the second page here. On the second page here, we have 9. Let's go back and look here. It says here, x squared. We have x squared minus 64. Okay, so here we go. On the second page here, we're now talking about here going to be the, slide this down. Sorry. There it is. The function is going to be 9m squared minus 81n to the 6th. This is also the difference of perfect squares. Now you'll notice that both of them have a 9 in common. If you didn't see that, you could you just pull it out later. But I'm going to pull a 9 out. I'm going to GCF the 9 out. M squared minus 9n to the 6th. That is a difference of perfect squares. Nothing happens to that 9. I'm left with m plus 3n to the 3rd times m 3n. Excuse me. Let's go. I don't know how do you erase? It's a minus sign. Sorry, ladies and gentlemen, it's a minus sign. I have no idea how to use this new thing. 3n cubed. 1 plus 1 minus. You have to have 1 plus 1 minus. It is important to make sure that one gets a plus and one gets a minus in the middle. Now, it could have been m minus 3n cubed and m plus 3n cubed, but it needs to make sure that you have one of each, because otherwise you will not get the correct information here. So if I look over here at this example, it says x squared minus 16, x plus 4, x minus 4. Okay, x times x is x squared. Negative 4 times positive 4 is going to give me negative 16. Y squared minus 100. Y minus 10. Y plus 10. Again, the order in which the plus or minus go is not as important. It could be in the first term or the second term. What's important is that it's before the 10. You don't want to switch the order. You don't want to do 100 minus y squared. That is very different. Some of us were switching order the other day for no reason. You're just making it harder on yourself. Please don't do that. I have here 4x squared minus 16. GCF the 4 out. I'm left with x squared minus 4. That's going to give me a 4, of course, and an x minus 2 and an x plus 2. Okay? Now, the bottom one here, let me slide this up a little bit, see if we can maybe see this. Right? And we have d to the 4th minus y squared. Now there's no number here. There's no perfect square number up front. So what I have here is d squared minus y. It's still d squared because when I cut the 4 in half, 4 cut in half is 2. So I have to have d squared and d squared times d squared plus y. Okay? Again, every one of these can be checked with FOIL, and you go back and make sure they're correct. Now let's take a look at these. We have some examples right here. If I look, 2 is not a perfect square, x cubed is not a perfect square, but if I factor a 2x out because I have a 2x in common between a 2x cubed and 8x, I'm left with x squared minus 4, which is a perfect square. And I have 2x here, x minus 2, x plus 2, because that's how that x squared minus 4 breaks down. Now number 6, I have a 4 is a perfect square, an x squared is a perfect square, y to the 4th is a perfect square, and 1's a perfect square, giving me 2xy squared plus 1, 2xy squared minus 1. Okay, I can't GC anything out of that one, but everything was a perfect square, broke down nicely. Now, if I look at the next one, I have a 10 in common. Pull that 10 out to the front. X squared minus, now I'm taking a 10 away, so I'm dividing by 10. This becomes 100. Y to the 4th. That is going to be 10 x minus, and that's going to be, right, because I'm going to break this down to be a 10 y squared, and then an x plus 10, that's a plus 10 y squared. Again, can all be checked with FOIL. FOIL it back all together. Last one on the page, last one for what we're doing here. The 6 is not a perfect square. I'm going to have to pull it because it has a 24 and they share a 6 in common. X to the 5th is not a perfect square. It's going to have to be pulled. I'm going to have to pull an x cubed out because that's the GCF. Y to the 7th is not a perfect square, but I have to pull a y out because that's the GCF. And the W is going to have to be pulled out. So I'm pulling that 6, right? I'm pulling that x cubed. I'm pulling that y, and I'm pulling that w. Leaving me with, the 6 is gone, the x, this becomes x squared. I got 1 out, that's a y to the 6th. The w's gone, the minus sign still lives there, big old fork from the 24. The x cubed, the y, and the w are gone. This is a GCF here. I have a GCF up front, there's a GCF right here up front. The DOPS is behind. Don't lose your GCF. 6x cubed, y, w, paren. Now I'm going to have x, y to the 3rd, minus 2, x, y to the 3rd, plus 2, right there. Okay? So what's going to happen there is, again, you can FOIL it all back together. You would FOIL together the two conjugates. Those are the ones with the different signs in the middle. And then you would FOIL in, when you were done, you just distribute your GCF. Okay? Obviously, folks, you can go back and rewatch this video. If you're stuck on something and you get asked questions, I'm going to be back as soon as I possibly can to help you with this. But this is what you need to know how to do. You need to know how to do DOPS. Okay? We did GCF the other day. Hopefully everyone did the practice GCF the other day. You got to make sure you understand how to do DOPS as well, because this is the kind of stuff that's going to be, this is the beginning parts, because we're going to get into factoring trinomials, and factoring trinomials is the biggest part of what we're doing. All right, ladies and gentlemen, so try these out. If you notice, you have homework, of course. Try those out as well. Key is online, but go back and watch this video again if need be. And I will